Hello everyone and welcome to the Solid State Watch. I'm Shannon Davis, the web editor for Solid State Technology, and now let's take a look at the top headlines we've been tracking from June 6th through June 12th, 2014. Entropic announced plans this week to close and consolidate several global facilities, a move that would impact approximately 23% of its headcount. In its official release, Entropic said that these plans are intended to align its cost structure around providing more focused engineering, research and development, and product development programs. Entropic offered approximately 30% of the staff in the facilities closing an opportunity to relocate to one of its California sites and expects to have approximately 500 employees at year's end. Entropic is offering transitional assistance to those impacted by the restructuring. A team of researchers from Purdue University, Semitech, and SUNY College of Nanoscale Science and Engineering presented at the 2014 Symposium on VLSI Technology on their work involving high-performance molybdenum disulfide field effect transistors. The team's research is an important milestone for the realization of ultra-scaled, low-power 2D molybdenum disulfide field effect transistors and the advancement of photonic and electronic devices based on transition metal dichalcogenide materials such as solar cells and phototransistors. In other news from the 2014 Symposium on VLSI Technology, researchers from the University of California, Santa Barbara will introduce the highest-performing 3,5 metal oxide semiconductor field effect transistors. The UCSB research promises to help deliver higher semiconductor performance at lower power consumption levels for next-generation high-performance servers. The research is supported by the Semiconductor Research Corporation. To reach this breakthrough in performance, the UCSB team made 3 key improvements to the 3,5 MOSFET structure. First, the transistors use extremely thin semiconductor channels, some 2.5 nanometers thick, with the semiconductor being indium arsenide. Next, the UCSB transistors use very high-quality gate insulators, dielectrics between the gate electrode and the semiconductor. And third, the UCSB transistors use a vertical spacer layer design. The overall design, construction, and testing of the transistor was led by UCSB PhD student Sang-Hoon Lee. ON Semiconductor this week signed a definitive agreement to acquire Aptina Imaging, a provider of high-performance CMOS image sensors for automotive and industrial markets. Other markets addressed by Aptina's products include cameras, mobile devices, and computing and gaming platforms. Now, under the terms of the agreement, ON Semiconductor will pay approximately $400 million in cash to acquire Aptina Imaging. The transaction is expected to close during the third quarter of 2014. For more industry headlines during the week, be sure to follow us on Twitter or like us on Facebook. For Solid State Technology Magazine, I'm Shannon Davis. Thanks for watching and see you next week.